Hello AI enthusiasts. I'm Banuprakash. Have you ever heard of lazy learning algorithm? It's fascinating, right? Let me feed something to your curiosity. Machine learning algorithms, such as linear regression, logistic regression, decision trees, random forests, and support vector machines study lots of examples to figure out patterns in relationships. Once they've learned these patterns, they can predict outcomes for new examples based on what they've learned from the past. It's like learning from experience and using that knowledge to make predictions about new situations. But there is one algorithm that completely differs from others in terms of work progress. Here I'm introducing Mr. Lazy Learner, a supervised machine learning algorithm named K-nearest neighbor. What is special about this lazy learner? Let's look it out. Unlike others, this KNN won't try to fit any line and doesn't make assumptions. Let me simply elaborate the algorithm quickly. The first step is data collection. Initially, we should have a data set that consists of features and their corresponding labels, which are nothing but the class or value we want to predict. The next step is choosing a k-value. The k in KNN stands for the number of nearest neighbors to consider. A higher k-value means considering more, and lower k-value means considering less neighbors. Then, what happens in the training phase? During the training phase, the algorithm simply stores the entire training dataset in memory. It doesn't perform any computations or learn any parameters. The next one is the prediction phase. When given a new and unseen data point for prediction, the KNN identifies the k closest neighbors to the new data point in the feature space by using Euclidean distance or Manhattan distance calculation. Once distances are calculated, KNN identifies the k nearest neighbors to the input data point based on the calculated distances. These neighbors are the points with the smallest distances to the input point. For classification tasks, KNN uses a majority voting mechanism among the k neighbors to determine the class label of the new instance. The class that occurs most frequently among the neighbors is assigned to the new input data point. In case of regression tasks, KNN calculates the average of the target values of the k nearest neighbors and assigns this average value to the new input data point. Since KNN doesn't learn parameters and doesn't spend much time in training a model, so it is called a lazy learner. This is the simple workflow of KNN algorithm. In real time, it can be used for spam detection, image recognition, recommendation systems, pattern recognition, and many other tasks. Finally, one thing to share is that this algorithm is limited to small or medium-sized datasets because it is computationally expensive and consumes more memory. It's time to go. Thanks for watching. See you later. Bye-bye.